Hello everyone. Here comes the last concept in chapter 5. You talk about how those electrons they are arranged in inside the atom. So that idea was once founded by a Danish scientist in the early 20th century. He called it Niels Bohr. So he suggests that the electrons they are moving around the nucleus, okay, in the circular orbit called shells. And the evidence is that they know if I do some electron excitation, right, on those atoms, the electrons will have their own emission or absorption, okay, in which we will see it as different color lights, just like flame test. It's exactly flame test, right? So, what is the and in this topic, we are going to talk about how those electrons they are arranged in different space. Okay, we call that an electron shell. Okay, each shell it is given a number. Then the shell nearest to the nucleus will be given the number. You may find the first shell, second shell, third shell, and fourth shell. The one which is the closest to the nucleus will mark it number 1, and next and each shell can hold a certain number of electrons, while the certain number of electrons can be found as a formula 2n square root, okay, 2n square, and while n we refer to the shell number. For example, n is equal to 1, you put it 1 here, you may get it what? 2 and 2 times 1 square, here comes 2. And then 2 times 2 square, we've got 8, 2 times 2, okay, 2 times 3 cube, we've got 18, and 2 times 4 squared, we have got 32. So you may get our different shells, they have their own accommodation, maximum accommodation of those electrons. So the way to arrange the electrons, they are in such a way we call that electronic arrangement. So you may while you are going to have some guiding principle to determine the electronic arrangement of atoms. First of all, while you fill in the electrons into shells, you are going to starting from first shell, okay, which is the closest to the nucleus. From the first shell, and second, you are going to start filling the next shell when the one shell is completely filled. Okay, so it is from 1, it is fulfilled, go to 2, fulfilled, go to 3. Do you get my point? So it will be also be expressed in terms of the following. One is electronic arrangement or electronic configuration, and one of them you may use the representation of electron diagram. In exam, you need to observe very carefully which item you're going to talk about. You talk about electronic arrangement of or electronic configurations, or you use the term electron diagram, you are going to put it as different way. For electronic arrangement of sodium, for example, it will give you something like this. Okay, how will I get to H1? You go back to the atomic number. Sodium have an atomic number what? Equals 11. Which means we've got 11 protons and 11 electrons. So we focus on electrons, right? How we replace the electrons? So you have to go back to the 2n square root. The first shell, it has an accommodation of 2, so put that 2 electrons. 1, we have fulfilled, we comes to put the second shell. Second shell, what is that maximum accommodation number? It is 8, right? 2n square. So it is 8. So which means you're going to fill that 8 electrons in the second shell, and here it has been fulfilled. We have got 2 times plus 8 equals 10, 1 electrons left, so we put the final electrons in the first shell. So we, in order to express this, right, the sodium, put sodium Na, the symbol, inside that circle, the smaller circle, and this is the electron diagram for the sodium atom. Okay, so how about have any shorthand method? You simply write down 2, 8, 1, which means first shell, second shell, and third shell, we have got the number of electrons there respectively. Okay, is that clear? So you are going to fill it until 18, okay? And for 19 and 20, potassium or calcium, the electronic arrangement is 28H1 but not 2H9. Calcium is 2H2 but not 2H10. So the first shell can hold about 18 electrons. However, it is some reason behind why the potassium calcium cannot fulfill it cannot fill on the in the first shell first. So for the following reason, it is out of the syllabus, and I would like for those high achievers, I would like to show you the reason why. I start from sulfur. Sulfur. Now, don't worry too much about that term. SPDF. Don't worry about that. No, you need not know what is that. You just focus on what. You just focus on the way to put those. And what happened? Take a look. Here. Sorry. So you just focus on and this. Okay. You need not know the PD, right? What is that? You just tell you the different number, different rooms that we are having. So we have got the first shell here, second shell, first shell, and fourth shell. So each of them, each of the boxes, so that each arrow will tell you 1 electrons and other electrons. Okay, so what is the hidden message? For first shell, it accommodates 2 electrons maximum. Second shell, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be 18 electrons, and etc. Right? Okay, you get a point. So as you are going to fill in those electrons in the according to the energy level. Okay, so you may see for the first shell we have got 1 circle, so that 2 electrons is, and that's it. How about second shell? Second shell we have got 2 hidden circles here. Right, 2 hidden paths. One is you put that 2 circles in the low energy level, the other 6 electrons in the second level. Okay, another level. How about third shell? Third shell we have got 18 electrons, so we have got 3 more partitions, right? We have got 1 for 2, the second is for 6, the final one is for 10. 1, 2, 3, 4, 5. Okay, 5 boxes means 10 electrons can be filled. So altogether we've got 18 electrons. But that is the most tricky part. Can you see that? For the first shell, for the final 10 electrons we fill in, it has the higher energy level than the fourth shell for the first floor, right? So that's why you may see this one, right, a little bit lower energy level than the 10 electron for those 5 boxes, which means that for sulfur you are going to have an electronic arrangement like this. We have got 2, 8, 6, right? Can you see that? 2, 8, 6. And then you jump to another one, which is argon. So what will happen for argon? You need to fill them like this. Okay, so it is 2, 8, 8. So what will happen for the other chemical, which is the first one, potassium, number 19. Potassium. What is that? We've got 18, 19. It's not here, it's here. Can you see that? It's here. So which means it is 2, 8, 8, 1, but not 2, 8, 9. Similarly, if you write down calcium, okay, it is 2, 8, 8, 2, because you are not going to fill them here. So what will happen to the next one? Yes, you may guess. What is the next one? Next one is scandium. Scandium number 23. This should be 21. Okay, 21 scandium. Scandium, what is that? We come to 2, 8, because that 2 has been fulfilled. What's next is to go back here. So altogether, we've got 9, 2. Can you see that? So that's why the first shell, the last 10 electrons can only be filled until the fourth shell for the first 2 electrons have been filled. Okay? So this is what I would like to talk to you about the electronic arrangement. It is a little bit out of the syllabus, but don't worry. You just appreciate what is that. And that is that. If you do not understand, don't worry. You just treat potassium and calcium as a very special case. Okay? It's not 289, it's 2861 for potassium, or for calcium, it is 2862. The two special cases. Now, so what's next is to refer to this page. You are going to fill in the electron diagram for electronic arrangement of the 20 simplest elements. Okay, and can you see that this page? You're going to put number 1 here. So what's next is number 2 here. Number 2, number 3, number 4, 5, 6, 7, 8, 9, and 10. You may find that this is from 11, okay, and up to 18, and here it is 19 and 20. So remember those different naming. 氫氦鋰鈹硼碳氮氧氟氦鈉鎂鋁矽磷硫氯氬钴. So altogether we've got 20 elements there. Okay, 20 elements there. So you are going to follow the steps just like this. You are going to find out what? You are going to find out the chemical name, atomic number here. So actually that 2 to 20 should be put here, right, instead. Okay, this should be number 2, number 3, number 4, number 5, 6, 7, 8, 9, 10, etc. Okay, so electronic arrangement should be here. So this is 3, which means what? It is 2, 1. Okay, can you get my point? So this electronic arrangement file for that is what? This is lithium. First shell, 2, second shell, 1. That's it. And this is lithium. Now spend some time on it. Okay, spend some time on it. And you may pause the video for a while upon finish. And I will show you the suggested solution after 3 seconds. 3, 2, 1. That is it. Okay, so what is that? So you may see the first 20 elements with their electron diagram and their electronic arrangement, as well as the chemical name, as well as the chemical symbol. Can you see that? From hydrogen to calcium. So what are they so special? Why do Mr. Chin give you such a diagram like this? A very strange diagram or a table. Can you see that? A very strange table. It seems that there is some pattern. There will be some pattern here. Yeah. What is the pattern? Can you recognize? Yes. If you see it from here, from this angle, right? From here, 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 and here. So what will you see? From left to right. So what will you see? Yes, they are quite similar. How similar it is? You may see that 1 circle here, 2 circle on this, in this row, 3 circles here in this row, and 4 circles. Okay, so what is that? Yes, that's right. It tells you the electrons, the number of occupied electrons shell. I repeat, it tells you the number of occupied electron shells, right, from downward. So what is that? From row to row. So what is that? We could call this one period. You may know it in the next chapter. Okay. How about if I take a look on here, on this way? So what are they in common? Yes, that's right. So can you see that the last digit, the last number, what are they? They will end it with the same number. Can you see that? Same number on each row. They will give you the same number of each row. So if I take a look on this side, what is that? We will call that the number of outermost shell. Outermost shell means the last shell to be occupied with the electrons occupied. Electrons, they are the same. So we will call this down the same group. Same group. So you will know this concept in the next chapter. Same group. Same group, downward. Same period, horizontal. Okay, can you see that? Yes, that's right. So remember the spelling, remember the order, and remember how to draw the electron diagram. Okay. If you have no questions, we may take a look on the last page on the checkpoint to recap what we have just learned. Checkpoint. Next slide is checkpoint. Draw the electron diagram for the atoms for the following elements. First one, carbon. Carbon, what is that? Carbon rank number 6. I give you a hint. Nitrogen is 7. Magnesium is 12. How would you feel that mean? First of all, carbon here. First shell, 2. And then second shell, the remaining 4 electrons. So here comes 4 here. 4. 1, 2, 3, 4. Okay, that's it. Nitrogen, the one next to it. So first shell, the same. 2 electrons for the second shell. The remaining 5 electrons. 1, 2, 3, 4, 5. Add magnesium. 12, right? So you may know that for the first shell, second shell, will both are fulfilled. So we have got 10 electrons already. How about the final 2? They are located in the third shell. Remember, you are asked to write down the electron diagram. What will happen if I change it to question 2? You are going to write down the electronic arrangement. So a very shorthand method. Atomic number is 8. So the electronic arrangement is simple, is 2, 6. This atom is one completely filled shell, and second electrons in the second shell. Full filled, completely filled, 2. One completely filled, which of course first shell. Okay, you're going to talk about first shell. How about the second electrons in the second shell? Second shell, 7. That's it. And finally, its atom has a 20 electrons. 20. How we get it? So the first one is 2. Second full filled shell contains 8 electrons, right? How about the third and fourth? Remain 10, right? We fill that 8 electrons of the first shell, leave that 2 in the fourth shell, and then continue on the first shell, right? So this is 2HH2. It is calcium. Just remember the element, what are they? Even though this one I did not ask you, it is a very good practice to get to to let you memorize the first 20 elements. So what is that? 2, 6, it is oxygen, right? Oxygen. 2, 7 is fluorine, and 2HH2, what is that? Yes, that's right. It is calcium. Okay, is that clear? How about question 3? An atom of element X has 3 occupied electron shells. 3 occupied, remember the term, which means what? 3 circles. And the electron diagram of its atom is shown below. Well, quite strange. Yes, that's right. Only electrons in the outermost shell are shown. So the hidden 2 circles in middle. So what is that? What is the atomic number of X? Okay, explain your answer. So altogether, what is that? We have got 2 more circles in between. The first shell, 2. Second shell, 8. Final shell, 1, 2, 3, 4, 5. This is 5. So you can get what is that? Yes, that's right. It is what? X is phosphorus. Lum. Phosphorus. So can you give me the atomic number of X and explain the answer? So it's easy. So an atom. So you're going to tell me the atom of X has an what? Has an electronic arrangement of 2, 8, 5. It which agrees with the sentence 1, 2, 3. 3 occupied electron shells. Okay, and finally is on this part 5 here, so which agree with this part. Okay, is that clear? So an atom of X has altogether 15 electrons. So the atomic number is 15. Why? Number of protons equals number of electrons for an atom, inside an atom. Okay, so you know that X is phosphorus. So remember the first 20 elements, what are they? It will help you a lot. Last but not, and in this one, we just talk about the electron shell. How will you fill in those electrons? Is from what? Is from the one which is closest to the nucleus, the first shell. Once it's fulfilled, you go to the second shell, etc. And this is what I would like to talk to you about this one. Any questions? Now, if not, I would just like to stop it here for for this one. Okay, so for the whole chapter 5, do you know the concept map, right? The concept map behind? Yes, that's right. We have got the concept map of atomic world. The elements can be exist as gas, liquid, and solid here, while the elements can be classified as metal, semi-metal, and non-metal. The main way of classifying them is by testing the electrical conductivity. Okay, for the elements which are the gas, liquid, and solid, so most of them I will find it, and non-metals is a gas. For liquid, we have got only two. We've got only two. One is mercury and what? Bromine. And how about solid? It can be a metal, it can be a non-metal, and semi-metal. And these two, the only two cases. Only two. One for metal, one for non-metal. And the elements can be represented by chemical symbol. So remember the chemical symbol, especially number 1 to 20, and some commonly used metals, just like 金銀銅鐵石, right? Gum is gold, silver, copper, iron, and tin. Of course, at least you should know that. And later on, the elements is the smallest parts of element we call it atom. Atom, we have got two main parts. We have got 99% empty space. Okay, which is the electrons that we may find here. They're moving around the nucleus in terms of shells. 2n square root, do you still remember? Okay, so you just say that how those electrons are filled. Well, n, it is, we call that shell number. Shell number. How about nucleus? The nucleus, it is 101% of the space, but it is nearly 100% heavy of the mass of the atom. We call it nucleus. And the nucleus contains something positive and something neutral. Electrons is something minus. Okay, the minus orbiting around that something plus positive, right? So the number of protons equals number of electrons. But the neutrons can be calculated. How? You check the term mass number in the full atomic symbol. So mass number, it is equal to number of protons plus number of of neutrons. Okay, while protons and neutrons number, they are equal, we will call that atomic number. Okay, atomic number. We may find these two in the atomic symbol like this. So what is that? Atomic number is this. Mass number is this. So I do hope you guys would get to know more about this. Of course, we not only have this, but also we have got this. How could I call that too? We will call that isotopes here, isotopes. So each of them would have their own relative isotopic mass here. So for chlorine, 35, the relative isotopic mass 35. For chlorine 37, we've got the relative isotopic mass of being 37. But can we get the weighted average of that? Yes, that's right, weighted average. Mass of all isotopes, here comes relative atomic mass. So for this one, what is that? We've got 75% of this, 25% of this. So you are going to times here, and plus. Here comes 35.5. Remember, no unit. Okay, no unit. So how come we will call that an isotopes? Because they have the same number of protons, but different number of neutrons. Okay. So I do hope by using this concept map, and you will know more. And if I have a final recap on this chapter. Okay. And I would like to stop here. See you guys in the next chapter, chapter 6.